Hey, this is Mr. Ward, and I'm going to talk about Geometry Do Now 20.2. Now, this looks a lot longer than it actually is. It's 4 multiple choice questions. I just take up a lot of space because I put some images in. So, who am I? I am the key. So, here we go. Which of the below choices would be best suited to prove Theorem 30? So, first you should read Theorem 30 and take a look at the diagrams and see what it's trying to say. This theorem says if two lines are cut by a transversal, so there's a transversal, such that a pair of alternate interior angles are congruent. So these two angles, they're between the parallel lines, so they're interior, and they alternate sides of the transversal. So if these two angles are congruent, then the lines are parallel. So that's what the theorem says. And so what you need to do is come down here and so the images really are too small, so I may just get rid of them. You want to figure out which of these choices down below does the job. So there's if two parallel lines are cut by a transversal, each pair of alternate interior angles are congruent. Well, that's a postulate, but this theorem is really just the reverse of it. So we can actually use that postulate right there. There are other theorems that talk about exterior angles. That's not what we've got. We've got one talking about corresponding. We got one talking about things being supplementary. We were looking for stuff that's congruent. So, and there are a couple others here. Two parallel liners, I got to fix that, are cut by a transversal. Each pair of exterior angles on the same side of the transversal are supplementary. Well, once again, that's about supplementary, and we're talking about alternate interior angles. And here we have perpendicular stuff, and we have nothing going on with perpendicular. So let's choose this postulate because that's the one. Because that postulate will help us prove this because it's basically the reverse statement of this. So this postulate says if these are parallel, then these two angles are congruent. But if these two angles are congruent, then we can flip that and say, therefore, these two lines, A and B, are parallel. Now, we get to Theorem 31. Which of these would be best suited for Theorem 31? So Theorem 31 is saying if two lines are cut by a transversal such that a pair of alternate exterior angles are congruent. So we're going to be looking for a theorem that talks about parallel lines leading to pairs of alternate exterior angles being congruent. So in order to prove that these lines are parallel. So let's find one. So if two parallel lines, so this is about alternate interior. This one's about alternate exterior. So that's what we're looking for. Theorem 25, if two parallel lines are cut by a transversal, each pair of alternate exterior angles are congruent. So we've been told that those alternate exterior angles are congruent. And if that's true, then that forces these lines to be parallel. So that's the option that we want to choose. Okay, let's go to the third one, 1C. Once I cut out those pictures that are just too small to see anyway, this will seem a lot shorter. So which of the following below choices is best suited to prove Theorem 32? Okay, here we're saying if two lines are cut by a transversal such that a pair of corresponding angles, these are corresponding, they're in basically the same sort of position relative to everything. They're like they rhyme in the parallel line and transversal setup. So such that a pair of corresponding angles are congruent, the lines are parallel. All right, so then let's look for a theorem that has to do with corresponding angles being congruent. So Theorem 26 says if two parallel lines are cut by a transversal, each pair of corresponding angles are congruent. That seems like the one. That's the one that's going to, so we know that we've got corresponding angles that are congruent. We reverse that statement and then that leads to those two lines being parallel. Now, Theorem 32, we're dealing with, I'm sorry for the choppiness here, I got interrupted. So if two angles are cut by a transversal such that the pair of corresponding angles are congruent, then the lines are parallel. So we're going to go down here and we're going to find the one, and we have found it. I just already talked about that, didn't I? So there we go. We've got Theorem 26, which says if parallel lines are cut by a transversal, each pair of corresponding angles is congruent. And Theorem 32 is really just flipping that in the opposite direction. So if two lines are cut by a transversal such that the corresponding angles are congruent, then the lines are parallel. So this is a theorem that is also a definition because it is reversible. So there we go, 32. And then the last one, looks like I have an error here. This is supposed to be Theorem 33. So I'm going to pause the video and fix it. So I fixed it, and here we go. Which of the below choices would be best suited to prove Theorem 33? If two lines are cut by a transversal such that the pair of interior angles on the same side, so same side instead of alternate side interior angles, are sup, the lines are parallel. Well, let's find one that talks about interior angles that are the same side. Okay, so we've got one about exterior angles, making it being supplementary. Here we have two parallel lines, so we've defined them as parallel. That's a condition. Then each pair of interior angles on the same side, or same side interior angles, of the transversal are supplementary. That is just that's just saying Theorem 33 in the opposite direction. So this one leads to them being parallel. This one leads, 27 here, leads to the pair of angles on the same side interior angles being supplementary. And so this one sets the condition that it's parallel. So that one leads exactly where we want to go. All right, I hope that helped.